Gabriele Lapi from the Department of Industrial Engineering of University of Rome Tor Vergata, and I present this work, Mechanical Behavior of Aluminum Sandwiches made by laser welding with the collaboration of Giuseppe Barbieri and Francesco Cognini from the Enea Research Center of Casaccia and Francesco Vio from the Department of Enterprise Engineering of University of Rome Tor Vergata. Now, aluminum sandwiches are interesting subcomponents for lightweight structure applied in the field of transport. A method to realize this kind of structure consists in welding together extruded profile to sheets. And in this work, laser technique was applied to joint a mock-up of a large aluminum sandwich panel. In this presentation, we'll talk about the qualification of the welding process and with digital radiography, tensile tests, SEM analysis, and micro hardness, and then the mechanical characterization of the sandwich structures. Now, for to realize the sandwich panels, were used rectangular extruded profile in aluminum alloy 60T6 and sheets in aluminum alloy 6082T6. And here you can find the chemical composition and the mechanical properties of these two components. Now, the welding process. Why we choose laser welding process? Aluminium welding process is affected by the issues of softening, in particular at the level of the heat affected zone. And laser allow to realize very narrow pits with the low heat input, and this minimizing the heat affected zone. And we use the power source that we use is an interbeam fiber laser system with an output power of about 2.3 kilowatt. Now, which are the challenges of a laser welding process, of aluminum laser welding process? The challenges are the aluminum reflectivity, the cracking susceptibility, and the formation of porosity. And to overcome these kind of issues, we develop a laser welding process with an innovative wobbling welding head that allows the focal spot rotation and the consequent mixing of the molten bath. This promises a reduction of the weld's porosity, that is the main defect in the laser welding process. Here you can see the wobbling welding head constituted by a collimator, a wobble module, and a focus lens. And in that graph you can see the diameter of the oscillation of the spots in function of the offset of the two prisms. And the maximum oscillation of the spots is about 2.9 millimeters. For the identification of the best welding parameters, a series of preliminary tests has been performed, and the target was to realize welds in compliance with the level B of the IEN 13919. And we investigate very large amount of parameters, but the more important was the diameter and the frequencies of wobble and the welding speed. In function of we analyzed the cross section of the welds and the porosity of the welds. Porosity has been investigated by digital radiography, and you can see by an optimization of the welding parameters a reduction of porosity, of macroporosity, or an absence of a macroporosity on the welding regions. The tensile test on the butt joints show a minimum value a kid of about 245 megapascals and this value is higher than the expected tensile strength of the main transport design standard that you can find in this table. Here you can find an optical image of the fracture surface of transversal tensile strength test, and the fracture occur in ductile wave, and in fact it's possible to see the presence of dimples in all the region of the fracture. Micro-hardness test on the three thermal joints show the characteristic W-shaped profile with the lowest value of hardness of about 50 meters in the heat affected zone of the extruded profiles. Now, the sandwich structures. We realize a sandwich welded together 4 extruded profile and 6 sheets. And in the right, you can find the section of the panels that we use for the mechanical characterization. The mechanical feature of the sandwich panel has been performed by 4-point bending tests in the true orthogonal direction of loads, and we use an electromechanical machine with and for measure the displacement of the sandwich, we use a linear variable displacement transducer. The results of the longitudinal bending test. In this figure you can find the test geometry, and in the graph the load profiles for 2 samples. The trends are very similar, and a first linear elastic stage until about 45 kilonewton, and then you can see a global plastic deformation until the maximum load value of about 58 kilonewton. And then a reduction of load occurred by plastic local deformation at the bunches regions. The results of the 4-point bending tests. Bending test was interrupted by the after the maximum value of LVDT as a kid, and without any crack, any visible crack on welds. The results has been compared with finite element, with those obtained with the finite element analysis, and the finite element model of displacement are modeled with shells elements with 4 nodes and 6 degrees of freedom, and a nonlinear analysis has been performed with an epsilon displacement at the punches, considering the contact between punches and sheets. And in the picture you can see the equivalent von Mises stress and the equivalent plastic strain, von Mises plastic strain. In the transversal bending test, you can see the test geometry and the load profiles. Load value is very low compared to the longitudinal bending test because the sheets are connected together and operate in independent way. But the test confirmed the good behavior of the welds and the ductility of the welds. And like the longitudinal bending test, the analysis, the finite element analysis, confirm the results, and you can see the equivalent von Mises stress and the equivalent plastic strain. Von Mises plastic strain. In conclusion, laser welding technology was applied in the realization of aluminum sandwich structure. Tensile test on the elementary butt joints confirmed that softening factor doesn't exceed the 18% of material by strength, like Europa 9. And the mechanical behavior of the assembly panels was investigated into 2 direction of load, and in this case the mechanical behavior of the panel is orthotropic, and the nonlinear elastic plastic finite element analysis confirm the results of bending tests. Thank you for attention.